Okay, so on this practice page, the first triangle that's given could potentially be an ambiguous case. We have to check. So look at the side opposite the given angle. 9 centimeters is opposite of 30 degrees. We can call that side A. Since 9 is longer than the other side, this triangle is not ambiguous. So I'm just going to write this here. And that's really helpful because we can just use the sine law as we naturally would to solve for side length A and B. So let's use the sine law. To get length A and B, we first need to solve for an angle within the triangle. Well, we have 8 centimeters that is opposite the angle B. So let's solve for angle B. I'm going to set up a sine law. Sine B over 8 is going to equal the sine of 30 over 9. I want you to solve for this sine law. You're going to write your answer for angle B, which I'll post the answers back on the website. Once you have angle B, you can use the sine law again to solve for length A and B, since you'll have angle C. To get angle C, you're going to do 180 subtract 30, which is angle A, and subtract whatever your answer is for B. Once you have angle C, you set up the sine law again, and you proceed from there. Let's look at the next question. I'm going to go to the next slide here. In this triangle, I want you to label side A as 4 centimeters. Now, side A would be the side opposite the given angle of 30 degrees. So on your handout there, I want you to put 4 centimeters along the side CB, and that's the given angle. Sorry, there's a duplicate of a B here. That shouldn't be there. You can just delete that. So now analyze your triangle. Since A is shorter than the other side, 4 is less than 8. Well, this is where we have this ambiguous case. We have more than one triangle that we can possibly draw. So how are we going to work this? Well, why don't I show you what those other triangles may look like? The first triangle is the one shown here, already on your page. 4 could extend down to angle B. But just like you saw in the other video, that 4 could also swing out to the other side. And you may have a triangle that looks like this. Okay, whereas before, if you look at it, right, that length was going to be there. There's the base of the triangle. So in this case, 4 would be there. The height, again, is still a line drawn straight down. So the question is, what type of triangle do we have? Well, here's where we got to do a little bit of work. So let me pick my marker here. That's going to be black. Let's do some work on the side. The first thing you're going to do is take the sine of 30 and you're going to multiply it by 8, since the sine of 30 equals h over 8. We see that from the 90-degree angle that's drawn there. H would be the height, 8 is the hypotenuse. So let's hypothetically solve for h. H is going to be 8 times the sine of 30. Let's do that in your calculator. We're going to do the sine of 30. We already know that's a special angle, which is a half. We're going to multiply by 8. So the height is going to be 4. Well, look at that. The height is 4, and so was the side that was given in the triangle. So what type of triangle do we have here? Well, we happen to have a right angle triangle, because the side opposite the given angle just so happens to be the same as the height we've calculated on the side here. So let's draw out what that would look like. Here's your 90-degree angle. Here's 4. Here's 8. And there's 30 degrees, right? Angle B would be 90 degrees because that's what we have there. So that's not always going to be the case. Right? If let's take the next part of that assignment. It's going to look like this. I'm going to move this over. So here's the next part of the assignment. How many solutions are there in each triangle? We don't have to solve. I'll do some of them and you're going to finish this off on your own. Triangle 1, angle A is 40 degrees, side A is 10, and the other side is 8. Well, again, I'll do a small sketch here. If angle A is 40, start off by drawing your triangle. I'll grab my pen. Just a quick sketch. If this is 40, that's 40 degrees, side A is opposite of this angle. So this is going to be 10, and this is going to be 8. Have I drawn that to scale? Well, that's where we have to look at our inspection. The side opposite the given angle is longer than the other side. This is not ambiguous. I'm going to shorten that. So how many triangles do we have? Only one. Only one triangle. And we have to draw it this way. Now, I haven't drawn this to scale. On your sheet of paper, you can draw your triangle to scale since we know that it's not ambiguous. There's only one. Let's look at triangle 2. Angle A is 38, A is 6, and B is 7. So I'm just going to draw an arrow here. I'm going to put this on the side. I'm going to draw 38 degrees as angle A. There's 38. Side A is 6. And let's put 7 over here. And we can label each corner. Say that's A, that's B, and that's C. Stick with this method of drawing your triangles. It'll make your life easier. So ask yourself the same question. The side opposite the given angle is 6. Is 6 shorter than the other side? Yes, it is. So this case is ambiguous. We have to do our check. And how are you going to do that? Well, same thing as we did before. The sine of 38 is going to equal whatever the height of the triangle is here. So I can draw a height down like this. We'll label that H over the other side, over 7. H is going to equal 7 times the sine of 38. Let's solve for H. Sine of 38 times 7. H is 4.3. Okay, now compare. 4.3, let's get red, 4.3 and 6. The height of the triangle is shorter than 6. Well, that means that the side length of 6 can actually be drawn 2 ways. I'm going to show you how that's going to work on a new slide. Here's the base. I'm going to extend this arm here, and I'm going to draw out my 2 possibilities here. There's the height of that triangle. This is 7. This is 6. And this is 6. Here's 38 degrees. There are 2 possible triangles that you could have. One triangle is here, the one I'm outlining. And the other triangle, let's use a different color. Use green. The other triangle is here. 2 possibilities. So the question is, how can we find these 2 angles? Right, again, this is A. B is either here or here. C is up here. What you need to do is use the sine law. Go back to my black pen. We are going to set this up to say that the sine of B, we don't know which one we're going to solve for first here, but just set this up, over 7 is going to equal the sine of 38 and 6. So let's do this work here. Let's solve for angle B. I'll let you do the math there. If we do this, sine of 38 divided by 6 times 7, take the inverse. We see that, I'm going to round, angle B is about 46 degrees. So where should you put 46 degrees? Well, look at your diagram. It's obviously not going to be this one because that angle is obtuse. 46 degrees is going to go here. There's 46 degrees. How do we get the other angle B, the other possibility for angle B? Just do 180 minus 46. So our other possibility is going to be 134 degrees. Okay, so two angles. What am I going to mark here if I give you a quiz or a test later? 46 degrees, 134 degrees, and you've solved for angle B. So in this triangle, we've solved for that angle, but you also have told me here how many triangles exist. Well, we have two because this case is ambiguous. I want you to try the same approach for triangle 3, 4, and 5. Follow the same instructions, and if you get two triangles, solve for the two angles. It's good practice for you. When you've done triangle 3, 4, and 5, look below, and there's a couple more examples that I want you to go through. Draw your triangle. Always stick with the drawing that I've used. A and B are at the bottom, C is on the top. The angle goes on the left, and draw the side opposite the given angle, attaching C and B.